Right, so question 5's got something we haven't had before. We're sketching a modulus, but then there's a -4 after the modulus. So what I would do there is sketch the modulus first and then shift it all down 4 once you've done that. So I would just start by putting in, I know that that 3 is going to be significant because that's the y-intercept, so I'm just going to put that in, 4, 5, 6, 7, 8, and then I'm going to sketch with using my pencil first of all, so I can get rid of it if I want to. Just y equals, I'm just going to do y equals 2x plus 3 first of all. So I know that starts there, and I'm just going to use what I know about gradients. Along 1, up 2, along 1, up 2, then back across 1 and down 2, back across 1 and down 2 would take me to there. So that means that it's going to be hitting the x-axis just there, and then going back up and reflecting. So I'm going to get at -1, we'll have that coming in again, and then when I've gone to -2, that's going to be level with the 3, and then back 1 more and up 2 more like that. So it's going to look something like that. And now I'm just going to go through the process of thinking through moving that down by 4. So from here, 1, 2, 3, 4, there is my y-intercept. Now that's going to get a mark, so I'm going to put that in there, and then it's going to have that same gradient, along 1, up 2, along 1, up 2, and I just need to mark that in. Now that means that we're going to be going through the x axis there at 0.5 or a half 0. So you get a mark for this one. To get a mark for the x-axis, you need to get both of the x-axes one, so we'll come on to that in a moment. This continuing on down is going to go, well, if this is at 0, it's going to go down to -4, isn't it? 1, 2, 3, 4. So there's my -4, and that is at -1.5. So -3/2, -4 needs to be identified there for another mark. You get a mark just for having a V shape. So if you've done this and not moved it down 4, you get a mark for that anyway. Then going across down, so the way I think I'd look at this is, I know that this is a distance of 1, 2 to the right, so it's going to be 2 to the left. 1, 2. So where is that? That is that's -1, that's -2, -3. So -3.5, which is -7/2, but you can write 3.5 if you want. 0 as well you need there. So that gets you your full 5 marks. And that is part A done. You can rub out that bit if you like. Oh, it's probably important to label that as being y equals 2x plus 3 take 4, so it's clear which one you want them to look at. Right, now finding the coordinates of intersection, we need to do a simultaneous equation, don't we? Now we're going to have to do 2 because we're going to need the positive version of 2x plus 3 and the negative. I'm going to start with the positive, so 2x plus 3 take 4 is going to be equal to -1/4 of x plus 2. Now you've got to be really careful here, and actually the mark scheme that I got this question from, they got it wrong. They forgot about that -4. So if you think there's anything wrong in my working out of these two things, please do let me know. because we're just going on whether or not I'm right now. So we'll then have, just clear that up, 2x take 1 is equal to minus x over 4 plus 2. Then if we take the x's over to this side, that's going to be adding a quarter onto 2. Well, 2 is 8 quarters, so that'll be 9 quarters of x is going to equal 3. Multiply by 4 and divide by 9 is going to give us 12 over 9, which is 4/3. Then we need the y value when x is 4/3, so I'm going to whack that back into this one because that looks a little bit simpler. So right, y is going to equal negative a quarter of 4/3. So 4/3, a quarter of 4/3. Well, if I times 3 by 4, I get 12. So it'd be 4 over 12 plus 2. Whack that into the calculator, and it gives you 5/3. So one of my solutions is 4/3, 5/3. Then the other one gets a little bit messier. You need to take the negative version. So the easiest way to do this is put the 2x plus 3 into brackets and put negative outside it, and then write the rest of what we've got going on here. So minus that, so that's like having a minus 1 outside the bracket. So if we expand the bracket, minus 2x, take 3, take 4 equals negative x over 4 plus 12. Then if we clean this up, we're going to take the x's over to this side, the numbers over to that. Got negative 7 already. Take 2 away from there, gets you negative 9. Adding 2 to minus a quarter gets you plus 1 3/4 or plus 7 quarters of x. Multiply by 4 gives you negative 36 equals 7x. So negative 36 over 7 is x. Then we substitute that value into the same thing that we had over here. In fact, I might do that over here. So y is going to be negative 36, but it's a quarter of it, isn't it? So a quarter means if we times the denominator by 4, 7 times 4 is 28, plus 2. Whack that into your calculator, and that should give you, I think, negative 22 over 7. So our other solution is going to be negative 36 over 7, negative 22 over 7. And that's finally done. So question 6 is quite a nice one, really. First thing to do is rewrite that as 1 plus ax to the power of negative 2. And then you just want to get your formula booklet, and here is in the binomial series, we're just using that part there. So I'm just going to start writing it out. So I know it's going to be 1 plus, and then it would be negative 2 times x, which is actually ax in this case, but we don't need to really worry about that bit. And then we're on to the next bit, which says n times n minus 1. So n is negative 2. 1 less than that is negative 3, and that's all divided by 1 times 2, or 2 factorial, as the way that we learnt it in class. And that just needs to be times by x squared, but x, remember, is actually ax. So this is the bit we're looking at, and what we're being told is that the x squared term is 75. So what that means is, if I just cancel that out first of all, and then a negative times a negative is going to be positive, that's going to give me 3a squared x squared. What they're saying is that that should be give us 75x squared. So we can then ignore the x squareds and just say 3a squared equals 75. Divide by 3. A squared is 25. Square root of 25 is 5. But remember the possible values of a, because it could be -5 as well. So that's the big part of the question sorted out in terms of marks. For part B, all you need to do is look at the next, is just continue that on to the next bit. So for the next bit, for x cubed, we would have -2 times -3 times -4 all over 2 times 3, which negative times a negative is positive, so we can just cancel all of those out, and that's going to be multiplied by x squared, or ax squared in this case. We know that the a is 5, so if we do it for +5 first, 5 cubed x cubed is what that's going to give us. Or you could have written 5x all cubed and then looked at that. That's going to give us -4 times 125 x cubed, which is -500. And then if you were to use the other one, the negative value of 5, that would give you -4 times -125 x cubed, which is plus 500 x cubed. So the coefficients of x cubed are going to be plus or minus 500. So question 7. The a plus b to the power x to the third. What you've got to remember there is that when we're doing that, we need, before we can operate it, we need to turn that a into a 1. And in order to do that, we need to take a factor of a to the power of 1/3 out of what we've got going on. So that gives us a to the power of 3 outside there. That means that can be a 1. We need to take a factor of a out of there as well. But then that will have the third part done when that's expanded. So that's okay for that so far. Now what we're saying is that when you expand all of this, if it didn't have anything there, that would give us 1. So our coefficient that we're going to get, instead of being 1, we're going to have to be timesing that 1 by 4 to get to 4. And what that means is we can say that a to the power 1/3 is equal to 4. And then all you've got to do is say that a is going to be 4 cubed, which is 64. Now there's the easy part. Now it's going to get a little trickier. We're now going to stick that 64 and 4 back into what we've got going on here. So my 64 to the power of third is 4. So we can now say that that's 4. There's me 1. And now we've got b over 64 x to the power 1/3. Now when this gets expanded, we're going to have to do the expansion rule stuff, and then we're going to times it by 4. So let's talk about that then. So we're going to have 4 outside of this will be 1 for the constant that we'll get, but then for the powers of for the coefficient of x, it would be n times x, wouldn't it? So it would be 1/3 times our x is b over 64x, and then it's going to continue on. Let's not worry about the x squareds because we don't need to. What we do know is that once we'd sorted out what this was, well, let's sort it out a little bit. So that's going to be b over 364s or 192. Once we knew that, we would expand this to give us 4 plus 4b over 192x, and that is what they're telling us up here. So we can then say that 4b over 192 is equal to negative 1/8. And we just need to rearrange here with times by 192 and divide by 4, so we will get b is equal to minus 192 over 8 times 4 is 32. 32 goes 6 times into 192, so that gives us a value of negative 6 for b. That's all part A. Part B, stating the range of values for which the expansion is valid. Well, remember, the x has always got to be, whatever this is here, has always got to be less than, the magnitude has got to be less than 1, hasn't it? So that it's a shrinking thing when it's expanding. So we're getting closer and closer to 1 value. So if we start doing that up here, what we can say is we know that we've got b over a, so we've got negative 6 over 64 x in our thing. But oh, hang on, got to remember we've got the 4 outside it, haven't we? Does that matter? No, it shouldn't actually. Sorry, just to make this clear, what we've got as our expansion, we know we've got 4, we've got 1, and then it's negative 6 over 64, which we may as well put in its simplest form as 3 over 32x, and that's all to the power 1/3, isn't it? That's actually what we are expanding. So this has got to be, the magnitude of it's got to be less than 1. So 3 over 32x, the magnitude of, is going to be less than 1. Now you're going to get 1 mark for saying that. So if you had 3 over 32 being less than 1, you could times by 32, divide by 3, and x is going to be less than 32 over 3. However, you've also got the negative version, haven't you? So it's also going to be between 0 and negative 32 over 3. So you all are going to have it anywhere in the region between negative 32 over 3 and 32 over 3. So that was B, and let's do C just here then. So if we go in, finding the value of C now, which is how many x squareds we've got. So we're going to continue on what we have here. So we know that we've got 4 with 1 take, I think it was 6 over 192x, there we could have simplified that, but that doesn't matter. What we want is the next bit. So on the next bit, if you look in your formula booklet, it is n times n, which is 1/3, times n minus 1, which is going to be negative 2/3. That's all going to be divided by 2, and then multiplied by x squared, but our x is actually negative 3 over 32, so it's going to be negative 3 over 32 x squared, and carry on. So what we are now saying is we want to know what C is going to be when we expand all of this up, and then remember to multiply it by 4. So we are going to be doing 4 times all of that stuff, and you can stick it into your calculator in one go here, as I have done. Actually, I just did this part and then I times that by 4, which should give you -1/256 for your value of C. Quite a nasty one there, but question 6 was quite nice. Right, question 8 then. It's quite a simple one really. This is the rule for what you do to one term to get your next term. So the first term is 4. To show that x, the third term is that, the first thing to do is to write down x2. So that's going to equal, well, 4 is going to be multiplied by p and then take 9. So then the third one is going to be p times what the second one is, which is 4p take 9, and then take 9. But then all you have to do is expand that bracket to get 4p squared take 9p take 9, and we've got 2 pretty simple marks. Part B, finding the value of p. This is the trickiest part of it. All you have to do though, it's solving a quadratic that has got a coefficient of 4. Take 46 from both sides, you get 4p squared take 9p take 55 equals 0. Then to solve this, well, we need the numbers that multiply to make 4 times -55 is -220, but that sum to make -9, or the difference between those two numbers, is 9. So 11 times 20 makes 220, and the difference between those numbers is 9. So I'm then going to write 4p squared. I want negative, so I'm going to go for the bigger number being negative, plus 11p, because that makes my -9p take 55 equals 0. Do a pair of single bracket factorizations on those. Take 4p out of there gives me p take 5. That means my other one is going to be p take 5. So 11 times p and 11 times 5. Good. So that means that our factorization is 4p plus 11 by p take 5 equals 0. So that means p could equal -11/4, or p equals 5. It says value, and this is where, because p is an integer, a whole number, we don't need that one. So p equals 5 is your right answer. If you write both of them down, you miss a mark. If you've just got 5 and you haven't actually found that value, it doesn't matter, but you shouldn't be showing both of them as your answer. And then all we've got to do is find the value of x to the power 5. So we know now that it is 5x to the n plus 1 is 5x take 9. So if we know that x to the third x, the third in the sequence is 46, the fourth in the sequence is going to be 5 times 46 take 9, and that is 221. So the fifth is going to be 5 times 221 take 9, which is 1096 as your final answer. And next time we will do the last 4 questions. Okay, cheerio folks.